In the earlier sessions, we have learned about introduction of carbon compounds. Now, we will discuss about the bonding in carbon, that is, covalent bond. At the end of this session, you will be able to understand about covalent bonding, Lewis dot structure, and types of covalent bonds. Now, before we learn about covalent bonds, let us recollect the basics required to start this session. That is, about ionic bonds. Ionic bond. The chemical bond formed by the transfer of electrons from one atom to another is known as ionic bond. Example, Kf, which is potassium fluoride. Here, potassium has 1 electron, and fluorine has 7 electrons in their valency shell. So, potassium has the tendency to lose the electron, and fluorine has the tendency to gain the electron. As potassium is releasing the ion, and fluorine is accepting the ion. So, potassium becomes positive and fluorine becomes negative. Then, the compound potassium fluoride consists of potassium K positive and fluoride F negative ions. Therefore, the bond formed by the attraction between the positive K plus ion and the negative F minus ion is said to be an ionic bond. Now, let us come back to the current topic, covalent bond. The chemical bond formed by the sharing of electrons between two atoms is known as a covalent bond. The sharing of electrons takes place in such a way that each atom in the resulting molecule gets the stable electron arrangement of an inert gas. For example, let us consider hydrogen molecule H2. The hydrogen atomic number is 1. So, the two hydrogen atoms contain 1 electron in outermost shell, and still they require 1 electron to fill the outermost shell. They share the electron pair to achieve the nearest noble gas configuration, that is, helium. Now, let us move on to the conditions for the covalent bond formation. Conditions for the formation of covalent bond. The combining atoms should have 4 to 7 electrons in their valence shell except hydrogen. The combining atoms should not lose electrons easily. The combining atoms should gain electrons readily. The difference in electronegativities of two bonded atoms should be low. Lewis structures. Lewis structures are also known as electron dot structures. The diagrams are named for Gilbert N. Lewis, who described them in his 1916 article entitled The Atom and the Molecule. Now, let us see the basics of Lewis structure. Atoms are written using their element symbols. Lines are drawn between atoms to indicate chemical bonds. Single lines are called single bond. Double lines are called double bonds. Triple lines are called triple bonds. Sometimes, pairs of dots are used instead of lines. Dots are drawn next to atoms to show unbonded electrons. A pair of dots is a pair of excess electrons. Steps for writing the Lewis dot structure of covalent compounds. Write the electron configuration of all the atoms present in the molecule. Identify how many electrons are needed by each atom to attain noble gas configuration. Share the electrons between atoms in such a way that all the atoms in a molecule have a noble gas configuration. Keep in mind that the shared electrons are counted in the valence shell of both the atoms sharing it. For example, ammonia, hydrogen fluoride and oxygen. Now let us consider ammonia, that is, NH3 for Lewis dot structure. Here, nitrogen atom has 5 valence electrons. Hydrogen atom has 1 valence electron. Each of the 3 hydrogen atoms will share its electron with nitrogen to form a bonding pair of electrons, that is, covalent bond. From the table, we come to know that hydrogen atom has 2 valence electron share, and nitrogen atom has 8 valence electron share while forming ammonia, NH3 molecule. Hydrogen atom achieves the nearest noble gas helium configuration, and nitrogen atom achieves the nearest noble gas neon configuration. Let us note that only the outermost electrons of an atom take part in chemical bonding, and these electrons are known as valence electrons. Now, let us see the electron dot diagram, that is, Lewis structure for ammonia. The nitrogen atom having 5 valence electrons is combined with 3 hydrogen atoms, which has a valence electron each. The blue and green electrons form a pair indicating the formation of covalent bond. Types of covalent bonds. Covalent bonds are of 3 types. They are single covalent bond, double covalent bond, and triple covalent bond respectively. Single covalent bond. A single covalent bond is formed by the sharing of 2 electrons between the atoms. Each atom contributes 1 electron for sharing. The shared electron pair is always drawn between 2 atoms. Hydrogen molecule and chlorine molecule are the examples of single covalent bond. Let us discuss about the chlorine molecule for single covalent bond. Chlorine atom has 7 electrons in its outermost shell, and needs 1 electron to complete octet and become stable. So, 2 chlorine atoms share 1 electron each to form chlorine molecule. Here, chlorine atoms achieve the inert gas argon electron configuration. Double covalent bond. A double covalent bond is formed by the sharing of 4 electrons, that is, 2 pairs, between 2 atoms. Each atom contributes 2 electrons for sharing. Example: OM2, that is, oxygen molecule. Let us discuss about oxygen molecule for double covalent bond. Oxygen atom has 6 electrons in its outermost shell, and needs 2 electrons to complete octet to become stable. So, 2 oxygen atoms share 2 electrons each to form oxygen molecule, and this can be represented with 2 lines between them. Here, oxygen atoms achieve the inert gas, neon's electronic configuration. Triple covalent bond. A triple covalent bond is formed by the sharing of 6 electrons, that is, 3 pairs, between 2 atoms. Each atom contributes 3 electrons for sharing. Example: N2, that is, nitrogen molecule. Let us discuss about nitrogen molecule for triple covalent bond. Nitrogen atom has 5 electrons in its outermost shell, and needs 3 electrons to complete octet and become stable. So, 2 nitrogen atoms share 3 electrons each to form nitrogen molecule. Here, nitrogen atoms achieve the inert gas, neon's electron configuration.